Hello, my name is Taejoon Kim. I worked at the Bernalor Lab at University of Minnesota, and my research for the summer is on P21 variant 2 as a biomarker for senescence in adipose tissue of female aging mice. So for just the background, P21 or cyclin-dependent kinase inhibitor 1A responsible for cell cycle arrest. Uh, this gene has actually two variants, variants 1 and variant 2. Variant 2, but not 1, is believed to be upregulated in Asian mice. Both variants encode for the same protein, but they differ in their first exons, as you can see in the graph to the left. This means that the transcription factors should also differ as a result. For my research, we primarily worked on adipose tissue, and this is because adipose tissue could possibly show signs of senescence much earlier than other tissues as mice age. And during my research, primary component has been using real-time QRT-PCR, as it can use to be measure the relative expression between age groups of these mice. So for my research question, is P21 variant 2 more upregulated in older female mice compared to younger female mice? So for the materials used, adipose tissue used were taken from the FVB C5-7B 1-6. I think it was commonly referred as F1 mice. The tissue were snap frozen, and there were 5 young and 5 old samples. For liver and the brain tissue, they were taken from B6 mice. They were also snap frozen, and actually, unlike what it says on this slide right here, there were only 3 young and 2 old samples for both liver and brain. And as mentioned before, the real-time qPCR thermal cycler was used to amplify cDNA to measure gene expression. To add on, I should also mention that the adipose tissue were taken from the perigonadal adipose depot of the female chow-fed diet mice. For the methods used during this experiment, it could be broken down into 3 components. The first was the total RNA isolation, where the tissue were first grounded up in trisol reagent, spun down, and the trisol layer was then added with the chloroform before spinning down again. This was then washed with, washed with isopropanol and then ethanol before finally isolating them down into a pellet before diluting them down again with RNase-free water. The second component of this experiment is the cDNA synthesis. cDNA can be made using the isolated RNA taken from the previous step using the reverse transcriptase kit. After the cDNA has been made, I then treated the cDNA with forward and reverse primers of the target gene that I want to measure and put them through the thermal cycler. So for the results, for the P21 variant 2 expression, there was a significant upregulation in the old mice compared to the young mice, unlike in P21 variant 1. There wasn't any significance, but it showed a strong trend towards older mice as well. These other genes of interest were also notable in their trend, except for P16, especially the pi1 expression. There was a significant upregulation in the old mice compared to the young mice. For the liver samples, both P21 variant 2 and P21 variant 1 didn't show any signs of change between young and old mice. However, in P16, the relative expression was higher in the old mice with a noticeable trend towards the old mice. As for the brain samples, P20 variant 2 showed a significant increase in older mice, unlike in P20 variant 1. This is similar to the adipose tissue as well. For the other genes of interest, P16, like in the liver samples, also showed a strong trend increasing in older mice as opposed to younger mice. And the other genes of interest didn't show any signs of upregulation or downregulation. Overall, P20 variant 2 is upregulated in both adipose and brain tissue in older mice, suggesting that variant 2 is involved in aging. P16 was upregulated in liver and brain, but not in adipose in older mice. Conversely, pi1 was upregulated in adipose from older mice, but not in liver and brain. This shows that different tissue have different senescence markers. In conclusion, the results obtained from these female mice suggest that further evidence of P20 variant 2 as a biomarker for senescence is shown. This is also a significant finding because previously this particular strain of mice was not tested for the P21 as a senescence marker, and this in fact did show that P21 variant 2 was upregulated in older mice of this strain, particularly in the adipose tissue. There was some limitation as well, as although strong trends were seen in liver and brain samples, the sample size for brain and liver tissues were pretty small, with there being N of 3 in young mice and N of 2 in the old mice. And that's it for my research. This concludes my presentation. I want to give special thanks to Dr. David Bernlohr for inviting me to his lab, and Herzl for guiding me throughout the summer, and everyone in the lab for welcoming me with open hearts. This is all thanks to the NIH SenNet CUSP internship program for providing me with this wonderful opportunity. Thank you very much.